It's Easter Sunday, and you know, on the seventh day and all that. So I thought we would uh, re restart today, the beginning of a new week, and only a few days left of doing this twice a day every day, and then we'll see sort of what happens after that, as I move into a new position, in fact. But today I thought we would just muck around and we would play with the concept of coding disaster. Not a coding disaster, but how to code a disaster. And so I'm just going to restart my chat so I can see who's in, and then we're going to get started, because I wanted to muck around today in Minecraft Education Edition with some code. Nothing that you're going to see today is anything I've done before, so really what we're going to do today is just sort of play around together and see what's what. We're going to see if we can do something brand new. Robbie Hayes is in with us. Good, Robbie. Good. How's tricks with you? We're going to click play and we're going to start on a new role. Let's see if we can, a new world. Let's see if we can code disaster. And by disaster, I mean natural disasters. Let's see if we can code a city in an earthquake. Let's see if we can code a tidal wave. Let's see if we can code a forest fire. Excuse me, I'm yawning. Let's see if we can code... What else? What other natural disasters? Give me ideas if you're in with me. Sick over the weekend, Robbie. This is a bad time to be sick, man. I hope you're okay. I mean, any time's a bad time to be sick, but this is a really bad time to be sick. So let's call this disaster. Creative, peaceful, doesn't matter. Infinite, because I want to see if I can impact the environment. Show coordinates for good practice. Always day, and perfect weather, although we might not always need perfect weather. But let's see what we can do. So today we're going to be coding natural disasters. Let's see if we can make it happen. I promise you, nothing we are about to do today is anything I've done before. So this is purely experimental. Oh, look at this village. I've never seen one of these before. Or have I? It's a savannah village. I think I might have. It looks great. So this is our village. We shall adopt these people and we shall see if we can code some sort of natural disaster for them. So first things first, I want to try an earthquake first. And the reason an earthquake is such a challenge and so difficult, and actually the reason I want to do this in the first place, is because I believe one of my biggest successes with Minecraft as a learning tool is in helping children to explore the real world, the geography, the science, the history, the mathematics, the literacy of the real world. What does it mean to live in a real world with rivers and forests, and the great thing is, if you're working with rural children who rarely, if ever, get to go to the city, you can build cities. If you're working with children who are landlocked and have never seen the beach, and believe me, there are children in first world countries who don't get to go to the beach, let alone those landlocked or even poorer countries where you are not able to access, even a beach holiday, for example, never see the coast. We can show them what the coast might look like and what it is to look at, to stand on a beach and look out at the sea. We can take children to forests, city dwelling children who never ever get that break to the forest, and that's just showing children different environments. What can we do in those environments? What if we were to say to the children of the UK, for example, who never have to worry about earthquakes? There are earthquakes in other parts of the world. People have to hide under tables and take drastic measures sometimes. There's another village. Drastic measures sometimes to avoid things like death from earthquakes and so on. We can show them that by modelling. Well, I think we're going to try, but we can certainly try and model that in Minecraft. Oh, this village goes on. Look at that. It's on this side as well. Right, okay. So let's head over to the other side and see what we can do. And I love doing that. I love challenging us, you know, children, education community, teachers to say, well, how would you do this? And why? The reason I love that is because things like when we did wind power in one of our streams a few days ago, there is no wind. And so we have to make it up. Nothing emulates wind in Minecraft, so we have to find a way of doing it. What if we were to do an earthquake? So first things first, we're going to press the C key, which is going to introduce our code. And we're going to go in and we're going to do earthquake. And we're going to see what we can muck around with. So first things first, let's have a look. We've got player. So on player, on chat command, on item used, on player died. Okay, nothing necessarily in there. Blocks, this is where it will get interesting. Fill with, so we might use a fill with. We might use on broken or on placed, because that could be like fracking. On placed, when something happens, i.e. when a drill is placed into the ground here, this happens. We might also use place. There's going to be a lot of these we can use. Test for sure. Fill with. Where are we? Print we don't need. With data 0, block by ID, block name stone, lever on block, nope, repeater facing, comparator facing, oh look at that. Replace with when block is. We might use replace with. Just trying to think through some of the things. Clone probably. Actually, we might use clone as a trick way of doing this. So there's our options at the moment for looking at, and this is one of the nice exercises I do with kids when we're using code builders. I say to them, before we make any code, go and see what makes most sense in the code blocks. Go and see if anything in mobs makes sense. Apply effect, mate. Apply, what would we have? Mining fatigue, haste, slowness maybe. In an earthquake we might, night vision, no, blindness possibly, nausea certainly, because that makes the screen shake. So we could do apply nausea to the nearest player for a duration of, so that might be quite handy. What else in mobs? Enchant, teleport, detect for block at, if found run command. No, okay, that will do. Agent, we don't necessarily need the agent for this one, though I will come back to agent and see if we can do that with him later. Weather, we could change the weather for sure. I mean, an earthquake may or may not come. I mean, earthquakes, I'm assuming, can happen on sunny days just as much as they can change. They can happen with stormy days. But we could definitely create a storm as a natural disaster later that might do something like that. Downfall, set time add, change game mode to survival. Nothing in there, I don't think. Show title, no. Although, what is that? I've never seen this before. On chat command run, show at P, title, start, subtitle, boo. Let's see what that is. I just want to see what that is now. So we're just going to go run. Am I missing something? Oh yeah, I am, look. It's because that wasn't right, okay. Oh look, start. But there's no subtitle. Where's the subtitle? I didn't know you could do that. Oh, there it is, boo. So boo appears this time. Don't know why it didn't appear last time, but anyway, that's great. And then it fades. So, if we're going to run a nice little piece of code, whoops. We're going to run a nice little piece of code. That's because I meant to close that. I don't want that open. We can, come on. We can do that. show, so we could have that running at the beginning. So let's do earthquake model, and then no subtitle. Let's just take the subtitle out. And then let's just see what happens. What does that look like on the screen if we put that up? Earthquake model, press play, and then let's just do run for run the simulation. Ooh, earthquake model, dun, dun, dun. Now we could capture a screenshot of that later. That is really good news. The only problem with capturing a screenshot of that is if we do it and then we press F1 to get rid of our HUD, that is our HUD. So that's not particularly helpful after all if we want to capture a nice screenshot of it. But anyway, now, first things first, what do earthquakes do? So when we head back into code, let's have a look at positions. We're probably definitely going to need some world positions, random positions, etc. Loops, we might want it to loop for a while, so we're probably going to need it to repeat a couple of times. Logic, if something, then do something, or else do something. If something is true or if something is false. We might need to set up some variables. We might need some maths. What else have we got down here? Functions. We can make a function. We can make an array. That's more about lists. Text. I'm not too worried about that. Builder. What does builder do? Builder teleports. Oh, this is like an invisible agent. Build a push state. Nope, that's not going to work. And then shapes. Circle of, sphere of, line of. Build a line of. Okay, so we might use line of. In fact, I have an idea for what that might look like. So, first things first, what do earthquakes do? The earth moves, so we're going to have a shift in the earth. Let's just put that at the top there. So we're going to have some sort of shifting of the earth, and then classic is cracks in the earth and some sort of crack and gap in the earth. So movement and the shaking of the ground, cracks in the earth, and then the collapse of buildings that are nearest to us. Now there's a number of ways we can do that, and the first is, if we're thinking about models, let's go back to our Minecraft world and let's remember something that we did once before. If I just find a gap here, see how we've got a height here of 72, 71, 70, 69, 68. If I do the following, I'm just going to try this. I'm just going to take a note of these coordinates. So that's, just clear my whiteboard. 19972 minus 31. Do that over here. 21971 minus 41. Okay. So if I do fill, and you can do a fill command straight into chat. Fill 19972 minus 31. 21971 minus 41, and then we're going to do stone. That fills that with stone, and then on top of that, I don't know why I got 71 there, but that's okay. Let's just do 71, 71, 72, 72 with air. No, sand. Okay. So if we have a layer on top, and we know that the layer below is uneven, and we have this earthquake layer, this is what I'm going to call the earthquake layer. Watch what happens when we get rid of the air. So we're going to make 71 and 71 fall. the ground collapses into the pattern that was the Earth. See how that happened? So let me just get a... We're just going to run a clear command on here. So on chat command clear, replace with air when block is sand at these locations, and that will be 199.68 minus 31 to 219. So this is just my clear command, 71 minus 41. Play. There, that should get rid of the sand. So then we'll run our command again. So let's just do this one more time. So we're going to do that for stone. Then we're going to replace the first one, the top layer, with sand. So this is our natural terrain, but we're going to build our city on top. So let's imagine our city was entirely made of sand. Let's just build some tower blocks. This is just a model, of course. And it doesn't have to be sand either. So for example, if we got grey, whoops. If we get grey concrete powder for roads, let's just imagine that we've got a road network here with, let's also get some of this in, and these are our cities. So our city sits on top of this entire platform. Let's just have so that's our city up there. Is that looking viable to you? It does to me. So that's our roads in between, and that's our city. There we are. The city of New York. Let's just make it even bigger, because I quite like this model already. Our banking districts and all sorts. We can get quite creative about this. Now, we don't know, I mean, at the moment I'm doing fixed pattern stuff, but we wouldn't know if this was going to be like an earthquake. We don't know what an earthquake's going to do. And so that's our city. And then what we do is, let me just, I'm going to take screenshots of this as we go along. Save Earth 1. Okay. Then what we're going to do is we're going to run our piece of code which gets rid of the stone. That's all. All we're going to do is get rid of that piece of stone, which nobody else needs to know there, and watch what happens to our city. At which point we can say, we can run a piece of code that says set random fires or whatever, but we can see what's happened to this. Now that's a massive earthquake, but if that was just, say that was one building, so actually we'll redo that. So let's do clear, gets rid of the sand, and that's the true pattern of the city. Buildings collapsed into the ground here, look. Towers stood up, but that's fine. So that's one way of doing it, is to have, and actually let me show you what that looks like in here, because to be fair, I only ran it in directly in chat command. But what I'd like to do is run that here. So I'm going to say on chat command foundation, and that's not going to be, that's going to be fill with stone. Doesn't really matter, but we're going to do stone in a world location that looks like that, and that's just going to be 71 by 71. So let's run that and see what that looks like. I actually need to do another clear as well, so let's do, because I need to get rid of, in fact all I need to do is put that and that in and tell it to replace with air when it is grey. That's interesting, it's GREY in the game and it's GRAY in Code Builder. Go figure. There's a bug. There we are, and we go clear. There we are, and let's do that again, because of course it needs to. I suppose you could just put that on repeat, and it would, you could repeat 4 times and that would get rid of everything. Let's try that later. So in this instance we're going to go back to C. So we're going to say foundation. In fact what we'll do is we'll just put stone, then we're going to put, let's just repeat this, we're going to make sand. In fact it's not sand, I want to make it, because we're just going to build the city straight away this time. So we're going to make it dark grey for our road systems, and we're going to make that on 72. So we're just modelling a city at the moment real quick. Kind of like you would with a sketch. If you were layering sketches, you don't end up with, I mean you don't start with this amazing comic sketch. You start with a rough pencil outline, then you darken certain bits, then you layer and move bits, then you colour the top, then you shape. You know, this is what we're doing. We're just modelling for the moment. So fill with stone. On top of the stone we're going to put our road networks, and then on top of our road networks we're going to do a clone. And that's because, let me just get this out of the way, I'm going to build a city. And we're going to work out how to, so that we can always just use the same model over and over again. And I'm just copying and pasting the word. I'll change these in a second, because our city then has to be here. Now what size is that? Seven, oops, 9, 10. It doesn't really matter. 11, 12. That's it. I just want a nice viable city model. Right, so let's start, because we're already doing the layer on top, so I only need the top layer, but I just want to map it out. Here we go, that'll do for our city model. Quite happy with that. So what we now want to do is take these coordinates, which is 222, 72 minus 36. And we want to take the highest one over here, so I'm just going to stop here and maybe go there, and we're going to go 230, 77 minus 41. So let's go back to our code and say that we are going to clone from 222, 72 minus 36 to 230, 77, no, 72, no, it can't be, it has to be 77 minus 41 into, and this is the bit I don't know yet. So I think we have to do that. If we're going to have a layer here and here, it has to be this layer, and I reckon around about I think it's going to be there. Let's try this. It might not work. We need to do some experimenting, but that's going to be 209, 73 minus 36. 203, 73 minus 36. Whoops. Just copy and paste those out now because that was a mistake on my part. Just 73 and then just take that out. There we are. Okay, let's play that then. And we're going to say what happens when we press stone. Oh, we end up with our city. Look at that. I could actually make the city a lot bigger. I could make the city a good bit bigger. So let's do that now that we've got a model in there. Again, these are just things that I'm using code because I know what to do with the code, but I've never ever done this before. I don't even know if we'll get to the end of this stream and an earthquake will be a viable option, but it looks like it might be. Because at the moment we're only dealing with the collapse. What I also need to do is deal with movement. But we'll see. The main thing is, again, what is it we're trying to teach? Always coming back to what is it we're trying to teach, because this is fun and it's problem solving, but what does it teach? And ultimately what it teaches is that our children are able to discern what an earthquake is, how it happens, because we're talking about the foundation principles here, moving, and we're going to talk about that shortly, because it might be that doesn't disappear entirely. It might be that just moves slightly. Maybe it shifts and part of a city collapses or something like that. But we're talking about, so these are our tectonic plates, if you like. We could maybe do two separate colours. But what we're really doing is we're teaching the geographical foundations of why earthquakes happen and why they matter. Yes, so let's work on that. Melissa Renchi has come in on YouTube to say, wouldn't it be amazing if we had a variable that became the magnitude? Totally. Let's make that part of our code. Let's see if we can do that. I don't know how, but we can do that. Whoops. Everybody's understanding the model that I'm making here though, right? i.e. this is New York, for example. I quite like that. I like that we have a city model with road systems and so on. So let's try that again. Let's just run stone. Was it stone? What was that? What was our code? Yeah, stone. Oh, that's interesting. That didn't work. Oh, it did. It's because I haven't extended the. It's because I haven't extended to here. So we're gonna. So it's 234. (77 minus 45). So we need to go back into our code and we need to go 23. or 77 minus 45. And then do stone. Whoops. I need to extend. Look at that, the city fell. Oops. I need to extend, therefore, the city forward. So that's interesting because I didn't extend the city forward. I must have only captured some of it. That's why we need to test. We always need to test our coordinates. Coordinates can be a real pain. The number of times I've had teachers message me to say, I built this world and it was meant to do this. Can you have a look and see why it didn't? And it's almost always coordinates. The code's great. The code works. Don't give up. It's the coordinates. I'm just getting rid of grass because grass can annoy me as well. So what I'm going to do is I'm going to extend this forward to, what would this be? This would be minus 2,6. So for our stone layer, we're going to do minus 2,6. And we're going to do that minus 2,6. So let's try that. There we are. So we get our city model. Now I have to leave that city model there, otherwise the clone will stop working. And I could hide that city model somewhere, but for the moment we're just going to leave it in there. And then what we can do is we can run our code that gets rid of oh yeah, because that's what I was doing. So yeah, we're going to use this one next. And actually, if we did test for air, that could be like a break in our, that could be testing for the break in our tectonic plate, but we're not doing tectonics yet. So then our final piece of this mystery is this. And we're going to call that quake. And we're going to fill with air from, and this just has to be the same as these ones. Wherever we put the stone, we replace with air. Press play. So, let's see if we can run all of this. We run a quake, and our city collapses. And we can discern from that model, I mean, we decided the pattern because of the pattern of the land, but our city has collapsed. And the only people that weren't affected were these people up here on the north of the city. And we can explore why. Maybe it's just the way maybe closer to the coast is more dangerous or something like that. Then, if we run clear... right. Hang on. Our clear needs to be changed as well. So that's minus 26. Minus 26. Once you have the figures, you know what you're doing. Minus 26 to minus 41. Clear. And we know that that takes 4 times. So what I'm going to do is I'm going to loop that. Four times. So let's get this in order. We're going to do stone first, because that's our laying the foundations. We're then going to quake it, and we're then going to clear it. So what you can see we're actually doing is we're computationally thinking over not just down the way, but across the way. So we're saying to our students at this point, show me a model of a city, which I can then run a model earthquake on, and then I can clear the model and start again. Okay? And our actual is build a layer of stone, build a layer of gravity affected, in this case, concrete powder rather than sand. Then we're going to do clone the city that we made earlier onto here. Then we're going to do make an earthquake by filling the stone layer with air, so everything that's gravity is then pulled downwards, assuming that there's a hole in the earth at this point. And then we're going to clear the model. So let's try this. So we run the first piece, and we run, what did we call that? Stone. We could call it city. There we get our city. The next one is we then run a quake on the city. And then the next one is we clear. Oh, I needed to do it one more time. Let's replace that 5 times. So let's do this again. And actually, I am going to change this to city. Where is it? City, quake, clear. City, quake, clear. Right, let's try that. Let me just get rid of, let me do clear first. There we are. Right, okay, so city gives us our city. Quake gives us our earthquake. And then clear gets rid of... That's really interesting. Why does that always leave 1? Let me do it 6 times. Ah, you know what it is? It's because it's not... It's because it's clearing too quickly and the blocks are falling. The code's already run by the time the blocks fall. We should just do that 10 times and see if it just does it anyway. Let's see if that works this time. I mean, of course it's going to work first time there. So let's do that again. City, quake, and then clear. Yeah, okay, right, 10 times did it. We just had to overcompensate for the gap in the gravity. I am really happy with that as a very... If a student came to me and said, this is what I think happens during an earthquake. There's a solid tectonic plate underneath the ground, and on top of that sits our cities or our landscapes and constructions and so on. Then what happens is there's an earthquake because those tectonic plates move. Invariably, whatever is on the top, because of either one piece being raised up or one piece falling down of these huge, inconceivably large tectonic plates, we end up with movement and collapse. Bianca Elizabeth, hello. And welcome to the stream on Mixer. And that then collapses into the ground, at which point we can, the clear command is just so we can start again. I would be really, really happy with that as a very basic descriptive model of how that happens. That's my basic understanding. I mean, I'm not a geographer. Right? So, anybody who's just joined the stream and watching, because I can see we've actually got a lot of people watching this morning. Anybody who's just joined us, we're trying to talk about how we might model natural disasters in Minecraft. We've just taken a random infinite world and we're now modeling a city model. We're then modeling a quake, and then we're modeling the clear up using code, and this is what our code looks like so far, to make an earthquake happen. Because of course Minecraft doesn't have these huge moving part concepts. I mean, we have pistons and things, but we don't have these huge moving part concepts. And so how do we code disaster? Which is why I've called this stream Coding Disaster. Not because we're having a coding disaster, although we might, but because we're trying to code disaster. All in the interest of helping students to understand real world concepts. So one more time, let's make a city. Let's quake the city. And then let's clear the model and prepare to start again. Barry's with us. Hello, Barry. Welcome to our stream. We've moved on to natural disasters if you're interested. Barry has a bit of an addiction now to making renewable energy machines. And so I feel it's my duty as the person who gave him that addiction to try and help him to move away onto something else. Something else to keep you awake, Barry. Earthquakes. So let's try this. Let's try something else then. What about if we were to look at the movement of... So let's model our city again, since we've got one. What if I wanted this to move? If I wanted this to be... Because here's the thing, if I make a crack in it, the city falls down anyway. And so what I kind of need to do is code that crack not to happen automatically. What I want to do, I'm interested in what this does. Where is it? Line of something from here to here. So let's test this in our model. Since we know we can constantly get our model back, let's do on player command line. Let's make a line of air from, and we'll just take our world coordinates, which we know is 71 is the stone height. And what I'm going to do is I'm going to take stone height from 215 71 minus 25, because we know it's one less, to, and we know that the stone is down here. I'm going to see if that line goes across the city, because I know we can do a straight line, I think that's obvious, but what if we did a line across the city? So then I'm going to do, so that's 202.71 minus 42. So that is, whoops, there it is there. 202.71 minus 41. Right, okay, we got it. Press play. So let's keep an eye on our city from above and see what happens if we run line. Oh my goodness. Hey, viewable sign 135, welcome to the stream on Mixer. We are trying to create models for earthquakes, and I think we just got one. So let me just run city, quake. Let's just collapse the city and then do clear, and we'll do that again because I just want that to disappear. Right, okay, so let's just run a model of a city. So there's our model of a city. And then what I wanted to do, and I tested for, was a line that then, this is our tectonic plate, and we're going to run an earthquake line that goes through the city. So let's see if this works again. So we're just going to do line, and this building here collapsed while this building didn't. And then what we could, right, okay, I've got an idea. So let me just quake. We have to do that to clear each time. Clear. Okay. This is good, right? This is working. I mean, but for so long I've thought, I wonder if we could make earthquakes in Minecraft to teach the concept of what they do. And I've never done it. But here's what I want to do next. City. Line. Now what I want to do, yes, so I think we should have multiple lines, and I think we should try a less harsh one, like 21172 minus 26, and then we should just do another one over to, say, there. And we should make that one 20771 minus 41. So let's run our code and see if we can do... now remember, we can run in one command, we can run multiple pieces. So we're just going to get that. So that's 21171 minus 36. And then 20771 minus 41. Play. So let's just run this again. Let's run city, quake, clear. And that just gets rid of it all. And then what we can do is we can run city and then line. That should give us 1 and 2 lines. Oh, it didn't. It did, but it technically didn't. Did I get my coordinates wrong? Why did it not run here? I think it did though. Let me just check my coordinates. 213, 215. What did I say? 211. So I said 211. So I was expecting more of a line here. 71 minus 215. Let me just double check I did that. Yeah, 211, 71 minus... Oh, minus 25. That's what I did wrong. So let's try that again. Let's do quake and then clear. We'll get to epicenter in a second, Barry. You're jumping ahead. You're that wee kid in the class with his hands up going, oh, 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 which, by the way, is exactly what I want. So don't be discouraged. I just think it's lovely. I'm thinking, I wonder if you can work out where the middle of this thing would be. Ta-da! The epicenter. So let's do city. And then let's do line. Oh, that was a beauty. Let's look at that from above. Let's look at that. So actually, we automatically have an epicenter anyway. This would be our epicenter because we have a line going here, which kind of did that. And then we have a line going here, which cross-references this one here. So that is our epicenter. But you're right, we could have them going straight across. And then we can look at, we can have the, so I'll tell you what we can then do. Let me just quake this and then clear. Okay. What we can then do is after line, we can do replace with. Oh, we're not allowed campfires. Are we allowed fire? Yeah, replace with fire when block is air between that. Let's try this. City, quake, no, line. Oh, it's only done one, but in fact it gave us the epicenter. I wonder why it only did one. Oh, because the rest are too deep. There's nothing to put the fire on. It could only be on a block. That's interesting though. And that's purely by chance that it gave us the epicenter, but even so. So I tell you what then, let's do, we need to quake it always before we clear. Okay. So the idea here would be, I think at the end we're going to do something with, I'm going to have to swap these. Actually, this would be a better, where's the village? There. I'm wondering if this would be a better one to do it on, or if we just replace with. Yeah, you could. So Barry says on Twitch, I guess you could include a pause using the code to give the shock and aftershock. So you could have the initial crack, then another crack, then a pause, then the collapse. In fact, let's do that. Now I'm lost. There. Let's do that. So what we would do, I just want to fix the fire piece though. I don't know if I want to replace with fire for air because it doesn't work. So we're going to have to replace Maybe that happens after the quake. Let's see what happens if we run quake. Let's do city, and then we do quake. Ah, the fire got put out. So it started, but it got put out because of the... So that's okay, let's just do clear. So fire is maybe not necessarily going to be something we can do initially. So let's try Barry's piece, which was city. And then we're going to do line, line. Then we're going to do loop, pause for 3 seconds. And then we're going to do quake. So let's do that. So we're going to do line. So line, line, pause for 3 seconds, collapse. I love code. That's fantastic. We still haven't got the left-right movement though. We still haven't got, and I think that's going to be hard because I don't know if that's going to involve some randoms, but that's okay. I'm going to have to do randoms. I'm going to come back to the variable that was the magnitude. Well, actually, the way the variable would work is if we wanted multiple lines. So actually, let's do that now. How much damage do we want? I don't necessarily think we need the collapse just now. I'll get rid of that just now because we got it there as a full quake. But for magnitude, and let me just clear up my... code. Let's just try this. So I'm in the city, even though it's just a model city, I know. So here I am, a giant in New York, Godzilla, roaming around New York, and there's a quake, or in this case, a line. There's going to be a line, and then there's another line. Pause for 3 seconds, and then I get, there we are, I forgot there was a pause for 3 seconds. Actually, that's all we need. The movement doesn't have to be the physical movement of... Yeah, we could make the fire afterwards. But what if we... Let me just quake and then clear. What if we did the movement as... So let me try this. Let me bring the city up. So what if the movement was just that? And then we wait 3 seconds and then there's an earthquake. So if I run line, the city shakes and some of it collapses. That was it. So let's do that again. So now what we're doing is we're modeling the effect rather than the actual movement. Let me quake that and clear that. And then city that. And then let's run. So let's just stand over here. So we're looking up 5th Avenue and we run line. There's an earthquake. And then there's an air. How's that for an earthquake? I love it when a plan comes together. And so back to the variables. Let's do quake and then clear. Because when we're finished this, I'm going to duplicate a city world and we're going to do the whole thing on a city and see what happens. We're going to turn the whole city into I mean, I can't promise it'll work, but I can try. And so, variables. And so a variable would be, make a variable, and that variable is going to be, what was the word for it that you used? Magnitude. Set magnitude to 1, which is 1 line. Okay. But we're not going to set it to 1. We're going to set it to a random logic. No, not logic, math. We're going to go into math and we're going to say pick random between 1 and 10. Let's do 8. It's 8s. And rather than having those lines there, I am going to do positions, pick random position. And I'm going to do random position to corner and random position to corner. That's how we're going to do this. What do you think? I haven't finished with this yet. I'm going to come back to that in a minute. But for the meantime, I'm going to get these corners first. Yeah, they need to be world coordinates for sure. So let me get city back up. And then I need this corner. So it needs to be this one. So corner 1, and I'm just going to draw this model. So corner 1 is 19972, or 7, it's actually 7, 1. Because we're doing the stone underneath, minus 41. And then the other corner is 21972 minus 41. And so that's what I'm going to put in here. Each of these is going to be a corner, and this is going to be the random. Actually, that's not true. I'm going to do this corner instead. Number 2 is going to be that corner, which is going to be 21971 minus 26. Okay, at which point I'm then going to do 21971 minus 42. 19971 minus 42. Okay, so that's the first set. So let's just deal with that first set. So let's say this is world coordinates, and we're going to do 21971 minus 41, and that's going to be 19971 minus 41, and that's going to be 21971, and that has to be the opposite. That has to be minus 26. Just making sense to everyone? I'm hoping it makes sense to me. And then that's the corner. We did that corner last time, and we're going to do any one of these. I'm even going to make the city bigger. No, that'll do, Okay, so this one then has to be, what would that be? So that was 21971 minus 26, all the way over to 19971 minus 25. All I'm trying to do here is create as much randomness as possible, because that's what earthquakes are. Well, the destruction they cause is random. We can't plan that, and we shouldn't really be trying to model that. So that corner is going to be 21971 minus 26. No, 41. We've already got that in place, right? 21971. Let me just double check this. That's not 219, is it? I've already done this. It's 199. Right, that's our corner. 21971 41 26. Yes. So these ones are 21971 minus 26 to 19971 minus 26. And then what we're going to do is we're going to set magnitude 2, pick random 1 to 8. And then we're going to loop. We need a loop. And this number needs to match the number that magnitude. So we're going to do repeat magnitude times. So we're setting magnitude to 1 to 8. And then depending on the magnitude, we get this number of lines. Does that make sense? Renchi, is that what you would do? You would set magnitude to, in this case, the computer says, oh, 5. We apply the effect, which I'm actually going to take out for the moment just so we can watch this. Then there's a pause. Then it's going to, and actually we can take the pause out for the moment. Then it's going to say, therefore, repeat magnitude times, i.e. 5 times. Except it's going to give us, that means it's going to give us 10 lines. So I think we take one of those out. Let's try that. Okay, so we should now do, not quake, line. 1, 2, 3, 4, 5. It did do 5. Woo, look at that! Yeah, that should then run the line 5 times, which I think it did. Let's try again. Let's do, and it's always coming from this corner out to all of those. So you see how it's just, so this is our epicenter. We've chosen our epicenter. I wonder if I should move the epicenter along actually. Let's move the epicenter to the middle here. And we can do 20971 minus 26. So let's do that. Let's go back to our code and do 209. Whoops. Nope, it was that one. What was that? That was 219. That's it. Right, okay. So let's try this again. Let's reset the model. So we're going to do... And here's the thing. I mean, we've got it so that it collapses down into the ground by like what looks like, if that's a model of a city, thousands of feet. But actually what we really would only have is we would have one solid layer underneath that, and we would end up with a disruption model of one fall, which would be fine. But we're going to do clear quake. So let's just quake it all down and then clear it. And then we run it again. So let's run city. And then let's look down at it from this time and run line. 1, 2, 3, 4, 5, 6. Oh, we got a magnitude of 6 that time, and look at the destruction there. Ah, this is so good. Right, okay. So let's do quake, clear, city, and then run line again. 1, 2, just 2, magnitude of 2 that time. So it's working. So we have a magnitude variable that allows us to decide, which is marked by how many lines we get, how many pulses we get from the epicenter. And we know we can change the epicenter to be anywhere on the map. It just happens to be in the middle this time. Yes, exactly. Super clever, random aspect, brilliant Richter scale lesson right there. It is, isn't it? It is, it's brilliant. I love this. So let's do quake. Let's do clear. Let's just run that one more time to be doubly sure, mainly because I like it. City, line, 1, just 1. Ooh, that was a small one. Okay, so let's go back and add our application, because now, so it sets the magnitude, it gives us the warning that an earthquake's coming because of the thing, it pauses for 3 seconds, then it gives us, now, pause for, I wonder if we can pause for magnitude. Ah, the pause won't be long enough. It'll pause for 8, which means there won't be a pause. We need to pause for 3000. So we need another piece of maths that says magnitude times. So pause for magnitude times. So the bigger the magnitude, the longer times 1000. So that will be 8 seconds, 7 seconds, 6 seconds, 5 seconds. So we're saying pause for, whichever you set the magnitude for, times 1000. And that means that the length of the earthquake, the length of time that we get the earthquake impact for, also matches the magnitude. Is it just me, or is this brilliant? He says, humbly. Right, okay, so let's try this. So let's run our model. So let's do quake, just so we can get it all down into there. Clear, we probably don't have to do that, but I like doing it. So let's get city back up. And then let's do line. So in this case, we're going to get a 1, 2, 3, oh look. We actually got 4 seconds there, but we only got 1 line, so maybe that didn't quite work. Let's test that again. Let's do line. 1, 2, 3, 4. It still only did 1 line. Oh, this should be a big one. 2, 3, 4, 5, 6, 5. Let's try this one more time with a clear city. Quake, clear, city, line. I don't think that's bad actually. I'm not entirely sure it's doing what it's supposed to, but it's certainly given us, if we were down at city level, ooh, that whole street just collapsed. So let's see if I'm going to just quake it, then I'm going to clear it, then I'm going to city it, and then I'm going to stand looking up 5th Avenue, walking cane by my side, and then I'm going to line it. Oh, there's an earthquake. Do you get no earthquakes in New York? I don't think you do you? Why am I on 5th Avenue? Oops. Yeah, I went down in the quake. I went down in the quake of 2020. You get earthquakes the other way though, don't you? You get earthquakes in Los Angeles. I just don't know any street names in Los Angeles. Though I've been there. Beautiful part of the world. Okay. So folks, let's try something. Let's go into Code Builder and save our code. So let's go up to our settings and go save project, and that's going to save an MKCD, and we're going to save that into our, let's just put it in pictures because I know that's where I keep the stuff that I'm working on with Minecraft right now, if that would work. This happened to me last time. Last time I tried to save Code Builder, it crashed. Yeah, that's not going to work. Okay, excuse me folks, while I fix this, I'll be back in a sec. There we go, Minecraft earthquake. Okay, actually it seemed all I had to do was click out like Windows out of Minecraft and go back in, and it seemed to kick in and work. So I'm not sure why that was the case, but it was. So let's go back to another world then. So I've saved that. What I'm going to do is I'm just going to close that down and save out of this world. It's really important that if you want to keep a piece of code, you save it, because it will disappear after 2 to 3 days in your cache inside Minecraft. It disappears, which I wish it didn't, but it does. So let's go and see if we can maybe do something with... I want to pick a world that has a city in it, a proper city. I have one. Why can't I find it? Oh, we could do it with the Pompeii toy box. Now, I don't know if this is going to work, but we'll see. Let's go back up to the top. This world must be around somewhere. I'm looking for a world called Immersive Education. There it is there, look. And I'm going to go into settings, and then we're just going to duplicate this world, copy. And that should put it back up to the top now, and we're going to go copy of Immersive Education. Right, let's go and see if we can turn this into a model for so here's our city, and what I'm going to do with that is I'm going to change certain buildings, not the roofs or anything, but just the materials that the buildings are made of. So what's this? Most of my buildings in this are made, like there's quartz, there's stone. So I'll tell you what, we're going to go into code, we're going to go into earthquake. I kind of want a new earthquake, but we can change the coordinates in this. So I'll leave this open, and in the meantime I'll do on player. I'll show you a little trick. I've showed you this before, but this is a really handy one if you want to quickly model things. So on player fly, let's move it down and get ourselves some room. On player fly, blocks, replace with grey concrete, where you find, in fact, let's do white concrete. So where you find quartz, we're going to do white concrete powder, and we're going to do that in a 10 by 10 by minus 10 minus 10 by 10, whoops, sorry, minus 10 by 10. And then we're going to do that where you find, now let's go back in and look at another model for, what do we got in here? We've got brick, so let's do brick for this one. So where you find brick, we're going to do some red concrete, no, brown concrete powder, and that's when you find brick block. And then we're going to do the same again, and we're going to pick a different one there. Where you find, what is that? Cyan terracotta. You're going to give me, whoops, that's not true, that needs to be cyan. Where you find cyan terracotta, you're going to give me grey concrete powder. Right, let's try this. So, whoops, as you can see, we've got the collapse of certain buildings, of certain parts of the buildings already. Just because of the way the building's designed. This should still effectively work though, even though the insides are collapsing. I think that's just because we've got floors and things being held up by them. Whoops. It's going to give you an idea. If nothing else, this is going to be a lovely model for city collapse in general. We could be the earthquake. Maybe that's our model. I don't know why the glass disappeared, but anyway. Look at this one. This one looks fine. This one's now turning brown, so we'll just turn this brown all the way around. I'm only going to pick the center area here so we can play around with the center area. We'd have to do some fixes on these buildings at some point. That's okay. It's a really quick way of changing what something's made of. And then what I'm effectively going to do is just, I don't know if we can take away the stone that everything's built on, because there might just be stone underneath it and everything just shifts down one. I think what we have to do is get a bit more clever about what an earthquake might look like on this particular model. But I'm just making sure, of course this is first step, is to make sure all materials are collapsible. So we're basically making sure that our city is collapsible, including our pillars in there. I'll go back in and fix that in a second. There's one over here I noticed. And then wherever you see quartz, we should be getting, yeah, there we are. It's not going to be good for these buildings. These buildings are going to collapse where, I'm not sure why though. It's like there was nothing, like, it would be it's door lintels, isn't it? It's wherever there's a door lintel, like things like that are going to disappear, but that's okay. We can deal with that damage. It's a model. It's not bad, considering. Staircases are collapsing. Okay, a bit longer. We'll try this, and if it doesn't work, I'm only going to try it once, and then we maybe need a bit more practice on another stream. But we certainly proved the model concept. What we now need to prove is... be interesting to see if you could build a city that could be modelled, because I've obviously not. I mean, because of the way I've built my city, I've obviously not built it in such a way that it could be a successful model. Look at that. That was not meant to happen. I suppose the other way you could have done this was you could have said, on earthquake, change these materials to, and then you would have seen what would have happened collapse-wise. Where was the weak points in your structure? So that actually, I could do that. In fact, we could do that with another duplicate. But in the meantime, let's just see what this looks like. Down into our space station. Right, that'll do. Said I was going to go in here and fix that. So now what I'm going to try and do, if this works, is I am going to take, let me just undo that now. I'm going to take a space between this building, so maybe let's just take this 1612 7192. I also think it's getting nighttime, is it? Is this not on always day? No, it wasn't. Look at that. And I'm going to take, this will do here at the other side of this building. One 721 71 185, and we're going to run to the other side of, where did I say we were going? We were going over here. Yeah, so I want to see if the cinema collapses as well, because we're going to run all the way over to, say, here. That'd be 1594 71 212. Now we're maybe doing this just a little bit too big. But what I want to try and do is I'll just run my, and I'll change my cinema as well. Cinema should be relatively safe as a building as it currently stands, but not when the earthquake starts to take impact. Yeah, we're starting to lose stuff up there, like, that's okay. It's just a model. Right. I'll do a quick run inside just to make sure. Whoops. That's because of door lintels. So important for the integrity of these buildings. You could do all sorts of things. You could say, right, we're going to change the internal here. Anything made of wool is going to be this. As long as you used the collapsible stuff like gravel and things. Right. So let's see. That's not bad. That's okay. I think I went from the corner of that building across. So what we're now going to do is we're going to go back in and we're going to go to our model for the line. And we're going to go set magnitude to 1 to 20. 20 is massive, right? Apply, that will do. In fact, I'm going to take that off just for the moment. Hey Chipster, thanks for the host. Great to have you in. And then we're going to do a line of air from 1721, this might be too big, 71 185 to 1594 71 212 into the corner, which was what we said was 1612 71 92. And then what we're going to do is we're going to see nothing. I think I got something wrong because it's meant to be happening here. Let's try that again. Oh, I tell you what, I'm doing 71 71. It's not supposed to be. It's supposed to be, let's do 61. Let's try that. That's still not working. What have I done? Oh, yeah, I have. What happened there? Why did that happen? I've got my coordinates right? Yeah, 92, 1, 6, 1, 2. Yeah, so we're supposed to be starting a line. Oh, there's one. So there's a line that cuts right through. Oh, there's another one. Yes, it's working. It's just not necessarily there. There it goes. Look. So we're not quite getting the massive impact that I was hoping for. Oh, there's another one appearing. Look. Oh, that is so. It is collapsing. It's just not causing the because everything falls in turn. So you end up with top damage rather than bottom damage. And that only worked to there. So what we'd have to do is we'd have to do repeat magnitude times. Yeah. What if we did, that's only dropping 10. What if we did drop 20? Whoops. So 51. I'd need it to be thicker as well. I don't want a single line of. That's okay. Let's try it again. Let's run line. It's working. It's just not nearly working as well as I thought. But we've identified our epicenter, which is somewhere around about here. And then we should end up with a series of lines appearing in our city. There's another one appeared. You'd have to have, and you couldn't have soft roofs as well to have the roof collapse. Maybe it doesn't work in a full city. That's a shame. I quite like that we've got these earthquakes though, that are making holes in roads. I like that we can just model an earthquake. And then what I'm going to do is, sorry, just give me a second while I also put one over here. And that's going to be 1735, 71, 74. And that's going to be 51. And that's just going to run to, say, inside here. 1709, 51, 178. Right. Oh, watch MCBC, thanks for the host. We're trying to make earthquakes work in cities. We're basically trying, these are earthquake lines, which are maybe or maybe not working, we don't know. Let's try this one then. So let's say that we're going to go from the same location, but we're going to make these ones 1735, 71, 74, 1709, 51, 178. Press play, and then do. So it's setting the magnitude between 1 and 20, and then it should, if I just look down on it, I don't want to go too far because I need ticking areas, but we should end up with the magnitude going out this way and then going out that way. So we'll end up with an arc. Let's see if anything happens here. We've got a collapse here somehow because of this one. Oh, there we go. So there's our earthquake going along. I wonder why it didn't go any further than this. How interesting. Well, that was it. Oh, there's another one. I suppose you could concentrate it all around one building, which is what we've done here. This would certainly be collapsing if I did a thing like, let's go to replace with fly. Let's do again. Let's say replace with that. In fact, no, we'll make it a lighter color. Let's make it magenta concrete powder when it is, it was another terracotta, wasn't it? It was the red terracotta. I think it's that. Or was it pink? Yeah, it's pink terracotta. There's a surprise. There we go. We'll lose some of that, but wow, what a difference between those two colours. We're losing the floors, which is okay. and we're not going to get, the stone is going to hold us in, so I'm going to have to change stone as well. So let's just do another one that says replace stone. Yeah, no worries, Barry. I'm almost done anyway, so let me just get stone. Who cares if it's a monster egg one? That's fine. Oh, that's because it has to be stone. Why stone is not... Oh, it's bizarre. Okay. So we're just going to move that building down. Come on. That building is now just utterly destroyed. Like, it didn't need an earthquake. It just needed me. Look at that. That's all pink. Oh no. So let's do that again. Let's run line, because we're running our piece of code, and let's see what happens. It's a nice way of testing the integrity of your building, though, is to use the code to swoop everything over and see what happens. Yeah, look at that. That building is just constantly in collapse because of our epicenter. Let's do that again. So you can see where most damage was done, even though technically not a lot of other damage is happening all around. I think if the buildings are too big, I think that's why the model was better. Let's go back to the model just to finish this then. Let's go save and exit, because I liked that, but it didn't quite do what I wanted it to do in terms of a model. So let's go back to our disaster model, run our code again, and this time we'll be able to... So let's go C. And this time I'm going to go import a file, choose a file. We're going to go into pictures now. What did we call it? In here somewhere is... I can't remember what we called it. It was Minecraft Earthquake, wasn't it? There. Go ahead. And that should give us, yeah, that's with our, so this was our final piece. So let's just run this simulation one more time. Let's do quake should collapse and clear should get rid of it. Okay, so the question at the beginning of this stream was, can we model an earthquake? Get out of here, period, all of you. Was easier. Can we, so what we did was we modeled a city by doing this on a scale, obviously, and then we ran a piece of code that set a magnitude that said we would get an earthquake shake, and then we would start to lose, depending on the magnitude, we would start to lose our city. We can run that again. So we get an earthquake, and then that was a big one. So we should get 1, 2, 3, 4, 5. That was 5. That was a magnitude of 5. And look at the destruction at our base, at our city's level. That's huge. And then what we can do is we can just quake it into the ground. And then we can clear it. All using code. So I'll finish just by showing you the code. So we modelled our city, fill a layer of stone, fill a layer of road, which is collapsible, and then clone the city buildings from another space. Quake would just be to fill the stone level with air, so everything collapsible did. Clear just allows us to clear it by telling it to change any sand or any collapsible material, basically, to air. And then repeat that 10 times, so it just keeps doing it as it falls. And then finally, our big earthquake model was set a variable called magnitude to a random number, 1 to 8, apply a nausea effect to us to give us the shaking screen, pause for the same degree of magnitude times 1,000. So if it was 1, we pause for 1,000 seconds. 1,000, technically that'd be 1 millisecond, so 1,000 milliseconds. And then repeat magnitude, i.e. repeat this number, repeat this action the same number of times the magnitude was set to. So if we got 8, we would get 8 lines from a random location, from a fixed location to any random location at the top of the city. That was our code. And that gave us a working model for an earthquake, which I've never managed to do before. I'm quite happy with that. I just wish it would work on a bigger scale. If you've got any ideas, PM me. Follow me on twitch.tv/immersive minds, mixer.com/immersive minds, or watch all of our Minecraft and education series on youtube.com/c/immersive minds. Thanks for tuning in. I will see you guys in a few hours when we're going to be back to our renewable energy toy box for biomass. See you then. Bye.